All right, this problem is dedicated to Gabby and Michael. So we've got our, this is 6.64 on the mastering. So we have our rider on the carousel that is, riding around in a circle. This is the view from either behind or in front of the rider. And so the place I'm going to start with this is actually doing the free body diagram for the rider. So I'm going to have a tension force pulling that way, and I'm going to have a gravity force pulling down on the rider. And I need to zoom out some so you can see all that. There we go. That's better. Okay. So just thinking about forces for a moment before I get into all the circular motion thing. I know that there's going to be X direction component of the tension and a Y direction component of the tension. And they asked me for the angle from the vertical. So we had a tragedy. We found the angle from the horizontal and we're, oh, it's wrong. Why is it wrong? Okay, so we're going to do it this way, and that's going to be better. Thinking about trig, ty is going to equal t times, let's see, that is cosine, right? Cosine of theta as the angle is measured here. And this one, oh, I forgot the t. T cosine of theta, and tx is going to be equal to t sine of theta. And then if I sum my forces, some of the forces in the x direction is just going to be tx, which is t sine of theta. And the hardest thing to realize about this whole thing, the circle is horizontal. What that means is that that force sum in the horizontal direction is going to be, there's acceleration there. Where's the acceleration? It's toward the center of the circle. That is centripetal force. So the other thing that you can apply here is that is equal to centripetal force. Okay, so that's going to be mv squared over r. So the important part out of this, what I'm going to take away from this is that t sine of theta equals mv squared over r. And I want to solve for that theta, but the problem is I don't know what t is. I can find v. They gave me enough information in the problem to figure out what v is. And they gave me r in the problem. And you might also be like, well, Mr. Reamer, you don't have the mass. Well, I'm going to make it cancel out in just a moment. So that's going to be fine too. We're going to kill two birds with one stone here, because let's do our force sum in the in the y direction. Okay, in the y direction, there's not acceleration in the y direction. So what we know here is that the sum of the ty and the mg must equal 0. Ty is up, mg is down. So when you solve this, ty equals mg. And then we know that ty equals t cosine of theta, and that equals mg. And so that means that t equals mg divided by cosine of theta. So I can take this and I can stick it in place of t up here. So when I do that, I'll get mg sine theta. Let's draw a line to separate that. Mg sine of theta over cosine of theta equals mv squared over r. And notice that we have m on both sides. If we divide both sides by m, the m's will cancel out. And that'll leave us with g sine theta over cosine of theta. Well, a very simple trig property to remember is that sine theta over cosine of theta equals tangent of theta. And that equals v squared over r. And I am running very low on room here, but what you can do then is you can divide both sides by g. So that's going to give us, I'm going to take this up here, divide both sides by g. That'll give us tangent of theta equals v squared over gr. And then I'm going to take the arctan or the inverse tangent. Make sure your calculator is in degree mode when you do your calculation, and that'll give me theta. So theta equals inverse tangent of v squared over gr. Now, just an aside, so this is the equation you're going to need to get the angle. Just an aside, to get the speed, to get v, just remember that v equals 2 pi r divided by t. And so they gave you the radius, they gave you the period for it to go around once, so you can figure out the v, plug that in as v here, plug in g times r on the bottom, take the inverse tangent of it in degree mode, and you should get the right angle. The correct angle, I shouldn't say right, the correct angle for that problem. Hope that helps.